so this is not the kind of thing you generally are going to review. Let's just start with a 1. And let's try to do these as fast as you can do them.
Okay, so it'd be -4.
Okay, number 2.
Oh, would it be 15?
Very good. Notice all the unnecessary numbers in there. We don't care if there's 4 oranges, 10 apples, or 2 dozen strawberries. The only thing we're focused on is the pairs.
Okay.
Number 3.
Would it be D?
Good. Really good. Okay. Let's see. Let me go to the next page. Okay. Here, let me get it down just a hair. Hold on. I want to at least get, well, there's the answers, 4 through 14. What's the area of that rectangle?
12.
All right. These are obviously pretty easy. That's okay. When they're easy, we can go through them very quickly. So. Number 5.
Is the formula 2 pi r?
Good. That's the formula for the circumference.
Okay. So would be A.
Yeah, they don't give you any formulas on the ACT, so you do have to remember the basics. And 2 of the most basics are the area of a circle and the circumference of a circle. So make sure you remember both of those. What's the area of a circle?
Yeah, is it 1/2? No, what is
Pi
it?
r squared.
Oh. Okay, thank you.
And I'll tell you how I remember that. You know how I remember that?
How?
Pi r squared, they're circular.
Oh.
So it's that frequently is the best way to remember something, is to think of it in a kind of a ridiculous manner. In other words, if you're picturing this big pie and it's squared, that's not the way pies look. They're circular. So pi r squared has a certain ring to it.
Oh, perfect. I'll remember that.
Hopefully that'll help. I don't know. It works for me.
Oh, it will. I get it.
Okay, good. Number 6.
I feel like it should just be F.
Yeah, this is fairly straightforward. A lot of these problems aren't this easy. In other words, this has only multiplication in it. There's no division needed. But this problem illustrates something that I want to go over. And that's, remember when you are looking at a problem that has 2 variables in the question, and every single answer has those two variables in it, that's a red flag for picking numbers.
Okay.
In other words, I can pick anything I want for X and Y. And remember in that ACT presentation, they said don't pick 0 and 1. So let's pick X of 2 and Y of 3. Now, the only reason I'm showing you this is because as these get more complicated, in other words, when they put in a third variable and division is needed, it's a lot harder to come up with which one is correct. But if you pick numbers, you'll always be able to do it. Notice that I picked the two lowest numbers. So how many olives am I going to need to fill 2 large jars?
96.
How many olives am I going to need to fill 3 small jars?
96.
So I intuitively know I'm going to need 192 olives, okay? Using X equal 2 and Y equal 3. Well, now we're going to go through every single answer, and whichever one produces this number, that's the answer. Well, it turns out that it's 48 times 2 plus 32 times 3. And none of these others, that's definitely not right. That's definitely not right. That's not right. And that's not right. I guess, actually, this could be right. Every now and then, they will give you a problem. No, that's 2 something. The only disadvantage of picking numbers is every now and then you'll pick numbers and you will find 2 correct answers. What do you do when you do that? You go back and you pick 2 different numbers and you check it against those 2 answers. And the second time will tell you for sure which one is correct.
Okay.
Okay. It's not very often. I rarely come across a case where I pick a couple of numbers and I find 2 different answers that are both that, especially if you avoid the numbers 0 and 1. Don't pick X of 1 or Y of 1. Those 2 numbers, 0 and 1, have special properties that not a lot of numbers have. So you want to kind of stay away from them when you're picking numbers. And again, if speed is the issue, you did it as fast as possible. Don't go through that method. The only reason I showed it to you is because it's going to come in handy on ones that are harder. Like I said, this was multiplication and addition needed only. So you were able to figure out without picking any numbers what the answer was. And you had it in 20 seconds. So that's by far the best way to do it if you're comfortable doing it that way.
Okay.
Some people just, especially if you throw in a problem where there's multiplication and division needed, then it's a lot harder to do just straight mentally. Whereas if you pick numbers, you'll absolutely know it. You know, if your life depended on it and you had unlimited time, then picking numbers always guarantees that you have it correct. So number 7. First of all, what am I going to do? What does f of x plus 1 mean?
Means you have to plug in what f of x is in for the
Tell me what I should write. So what is f of x plus 1 equal to? F of x plus 1. How am I going to solve that? What should I write? Exactly. Don't do any math in your head. Do the plug-in first, always, even if speed is an issue.
Okay, would it just be 3, and then you plug in that squared plus 4?
That's what you do, is wherever you see x, you plug in what's in this parentheses. No matter what it is, you plug it in whenever you see x. Okay?
Okay.
Now what's the next step? I still got a lot of work to do here because I don't see that in my answers.
You just solve it?
Clearly I don't have to solve it. It's not an equation, but I gotta simplify that.
Yeah, simplify it.
So what's the first step in simplifying?
You have to do the exponent.
Okay, get rid of that exponent. What am I left with?
So then it would just be 3x squared plus 5.
Hold on. Let's not do that math in your head. What is this squared? That's what I want to write next.
So just write it twice then?
Well, it's x plus 1 times x plus 1. What is that? FOIL it. X plus 1 times x plus 1. That's the next thing you have to do in this problem. What do you get when you do that? In other words,
X squared.
Okay, go ahead.
X squared plus 2x plus 2.
Plus 1.
Plus 1.
One times 1 is 1, not 2.
Yeah, I'm sorry. That was a silly mistake.
Okay, it's a common mistake. So that's what I have to write in there. And I've got to multiply the 3 times all 3 of those terms. And I still have a plus 4. What's the next line?
3x squared plus 6x plus
I'm done. I'm done. There is only one answer that has that as the first 2 terms. So if you're looking to speed up, it's always a good idea to check your answers. And when you're doing this math, when you get to this point right here, there's no need to finish it. And finishing it isn't that hard. It's plus 3, plus 4. So you have to change that to plus 7. But all that takes seconds. And it's amazing how often the ACT will put answers on there where you don't have to finish the math. It's incredible. I would say half the time. When you do the first part of the math, you've done enough to answer the question. And remember, that's the purpose. It's not to show anybody how much math you know. It's to answer the question as quickly as possible. I have to use a new technique for some reason. I'm not sure.
Oh.
But the old way I used to do these doesn't work anymore, so I have to look at them under paint.
Oh, fun.
Well, it takes up a little bit of space on my screen. I can't figure out why I can't. My old software doesn't do stuff like let you zoom in and out or rotate the picture. So.
Oh, that's weird.
Yeah, and I definitely need to zoom in and out. So. Okay. Number 8 is a really good problem because the calculator is not going to do you a lot of good on this problem. And I almost feel like saying that that's the case for the whole test. If you go into this test thinking your calculator is going to help you, it'll probably hurt you.
Will it slow you down? Is that what you're saying?
Yeah, this is a perfect problem. You have your calculator in front of you?
Yeah.
See if you can get the answer to this as quickly as possible.
Okay.
With your calculator.
With my calculator?
Yep. Just I'm going to test it. I want to test it, and I will show you why you don't want to use your calculator on this problem.
Okay.
But maybe. I don't know. What do you have, a TI-84 or an Inspire or what?
I have TI-84 Plus.
Okay. That's legal. Good. The Inspire, certain types of the Inspire are not allowed on the test. But.
Oh.
the TI-84 is. But even the TI-84 is going to make this problematic. I don't know. Work on it for a little bit and tell me what you think the answer is.
Okay.
I'm assuming that would probably be your first choice if you came upon this problem on a test, would be to use your calculator.
Yeah, probably.
Now you can get the answer with your calculator, but you almost have to think out of the box a little bit.
Uh-huh.
The reason is they put so many answers very close to one another. These two answers are really similar. Ooh, look at this. I can write on this thing without taking a screenshot. How nice. Oh, I just discovered that. I've never done this before.
Oh,
I
so fun.
screenshot and I can write, but I can write directly on this when it's in paint.
Oh, that's nice.
Yeah, I can probably erase. Whoops. I want to do that. Let me undo that. Let's see. Okay. So, did you get an answer yet?
Oh, I'm still working on it.
Okay.
Sorry.
That's okay. I've been talking, so I interrupted you, but
No, it's all good.
the problem is that your calculator gives you an answer in decimal. It doesn't give you an answer in fractions.
Oh, I got an answer. Well, I just
Yeah, no, you can get it. You can test out each of these fractions to figure out which one is the
well,
decimal.
I just found a common denominator and then just
That's the way to do
added. But I have such a big number, like 258 over 144.
it. Well, let's go through that process because I want to show you the easy way to do it if you're doing it manually, which is what you just did. You did it manually, right? You didn't really use your calculator.
Yeah, I just did it for multiplication, but
So here's what we're doing. We're gonna take. Hold on. Must be. Yeah. We're going to take the fractional part of each one only. And I'm going to add those three fractions, knowing that the other three numbers add to 9. So what's the least common denominator for these three fractions?
24.
Okay. That's the first fraction in 24ths.
What?
This fraction here, how many 24ths is it?
Oh, 4,
It's 20.
20. Oh, because then you do 4 times. Okay, yeah. 5.
What you do is you divide 6 into 24, take your result, and multiply it by the numerator.
Mm-hmm.
Okay? So how many 24ths is 5/8?
3. So 15 over 24.
And how many 24ths is 1/3?
8. So 8 over 24.
Okay, now what do you do?
Just add the top.
Okay, that's 43. And remember, we still have 5 plus 3 plus 1. So what we really have is 9 and 43 24ths. You with me?
Mm-hmm.
So we know one of these three answers is the right answer.
Yeah.
Because how do I convert 43 24ths back to a proper fraction? Because all my answers are 10 and something. So what is that equal to in terms of my answer?
Oh,
What do you do with 43 over 24? What's that equal to?
just divide it.
And what's the result?
1.8.
See, that's a fraction again. It's not 1.8. Don't do it on your calculator. Do it by dividing 24 into 43. You get 1 and 19/24 is the remainder. And you still have your 9.
And then you add it.
And so now you got 10 and 19/24, and you know your answer. Now, notice that you were well on your way to answering J by rounding off and using your calculator. When you divided 43 by 24, you got 0.8 because you rounded it off. Well, that's what that is 0.8.
Mm-hmm.
So this would be really, really easy to make a mistake by using the calculator. And I'm not saying the calculator wouldn't help. You could certainly do that in your calculator. You would come up with a fraction that was 10.8 and change. More decimals and digits like that. Now you know that it's either that one or that one, and in your calculator do 19 divided by 24 and see what decimal you get. So you could do it that way. In other words, if you use your calculator to do this problem, then you're going to have to do a little bit of back solving at the same time, because you're going to get a decimal like that, something that looks like that, and you're going to have to figure out which of these answers is that decimal. Well, that's not that hard. We know it's greater than 10.8. That's 10.8. It has to be that one. Okay? So you could solve it with a calculator, but the easiest way almost is to just do it manually.
Okay.
All right. How about number 9? Are you drawing a picture?
Yeah. I think I almost got it though.
That's the way to do it.
Is it B?
Yes. All right. Another problem that I've always liked. And there's a hard way and an easy way. Almost every problem on these tests, there's a hard way and an easy way. And by that, I mean a short way and a long way.
Wait, is it F?
Yes. And I'm assuming you did it by figuring out the total new pieces was 12, right?
Yeah.
Just dividing that by 2. You could easily go wrong here if you took a different strategy and figured, well, first week I'm going to do 3 new pieces every 4 weeks and 2 new pieces in the first week. In other words, I could get kind of lost in the woods if I didn't recognize that it's a real simple problem. You just have to do 3 times 4, which is 12, and divide by 2. Okay, let me go pull up the next one. Let me ask you something, Haley. Did you get a report on your first ACT so that you know what you got right and what you got wrong?
Yeah, I did. On the last one that I took.
How was your geometry? That's what I'm trying to get at.
It was pretty good.
So you weren't weak in geometry?
No, it was pretty good.
Okay, that's fine. Because I do have some practice tests that are all geometry.
Oh.
And the only reason I have them is because you get a lot of students who it's been 2 or 3 years since they took geometry. So they
Yeah.
be weakest in geometry. But if that's a good subject for you, then we don't need to do those kind of practice tests, geometry only ones.
Okay.
But it could be useful. We'll just keep going on through these tests. I've always thought these problems were very good.
Okay.
And let me ask you this, have you done any of the practice tests in the booklet you got from Sycamore Learning?
I've actually been doing a lot of the ones online that I have through the program that I do on it. So no, I haven't.
Well, that's okay. I just wanted to make sure that I didn't give you stuff that you'd already done.
Oh no.
Because I have that booklet, and if I run out of tests over the next, I don't think I will. I've got enough to cover 4 hours. But if I were to, I can do some of those that are in that book if you haven't done them already. Okay. So,
Okay, thank you.
yeah, what's this one here?
80.
Okay. First of all, tell me if you know how to do this.
Sorry, what?
Tell me if you know how to do this.
Um, I don't know. I kind of sometimes I get these ones, sometimes I don't. So like I'm adding.
There's a lot of average problems on the AC.
Uh-huh.
Okay. And the key to average problems is one word, totals.
Okay.
Okay. Just always remember that. It's never about comparing averages, ever. It's always about totals. So that tells me the very first thing I have to do here is total those three numbers. What is that total?
505.
The next thing I have to do is if I want to average exactly 175 over 4 games, what do my total need to be for 4 games?
So could I just like try them all, like all the numbers?
No, no,
Do it that way?
no. Just figure out what the total needs to be for 4 games. You know the average, you know the number of games, so multiply 4 times 175, and that'll give you the total number of pens you need. That's 700, right?
Yeah.
Okay. This is how many pens we need in order to average 175 for 4 games. This is how many pens we've gotten through 3 games. What do I need to bowl on my last game?
195.
Exactly. Notice I did not try to figure out the average of those 3 games and compare it with 175. That is never the way to go on these average problems. It's
Will I get the right
always
answer?
figuring out totals. If they give you some numbers, you got to total them up. If they give you an average for 4 games, you got to total it up. Remember what average is. It's the number of scores divided by how many games. In other words, if I wanted an average for these first 3 games, I would do 150 plus 195 plus 160 divided by 3. That would be my average. Well, notice that if I take 3 times the average, I get my total.
Mm-hmm.
So that's why I'm going to take 4 times the average, 175, to know that I must have 700 total pens or 700 total points of score.
Okay.
I'm going to go ahead and draw this. This is one of those cases where this is what you should do. Okay. In other words, when you see problem 13, as quickly as possible, draw. There's 1 point. And don't worry about exactness or precision.
Okay.
In other words, my next point is somewhere up there. Okay? I don't care if I have these things in the right spot, especially in the context of the problem. The problem says if you have a triangle with those 3 vertices, now let's see if we can answer the questions. Is A correct?
No.
Is B correct?
No.
C?
No.
D?
Yes.
Which angle measures 90 degrees?
Oh wait, did you say E?
No, I said D. I'm going
Oh,
through
sorry. No, D's wrong. E is right. Sorry.
E is right. And you can readily see it by there's the angle that's greater than 90 degrees. That's the obtuse angle.
Mm-hmm.
And notice that it didn't matter if that point, maybe that point actually I ended up putting it at 4.6, who cares? In other words, in the general area is all you need. Certainly do not take the time to label a grid like that.
Okay.
Take time and it would be a waste of time. You don't need to do that. And you can generally do that whenever you're drawing a picture based on the XY coordinate plane. Approximate. You don't need to put a grid down and you don't need it to be exact. You just need to kind of get a general idea of what this triangle they're talking about looks like.
Okay.
14. Work me through this verbally out loud as to how you're going to do it.
Okay. I would.
To quadratic, what does that mean? You're going to have to do.
Oh, quadratic formula?
No?
No.
No, you might have to know the quadratic formula for this test, but you don't need it for this problem. In other words, that's the hard way to do this problem. There's an easy way to do this problem.
Factoring?
Yeah, just factor it. Now, whenever you're considering factoring something, always look for greatest common factor. Well, what can I do immediately?
Are you saying factor it?
Take out the 2. I'm looking at all even numbers.
Oh.
That's an even number, even number, even number. I know I can divide everything by 2. Now I can divide everything by 2, and that goes away. I divide left and right side by 2. And the reason that's useful is because now I have a very simple quadratic to factor. Hold on 1 second. I'm hearing some noises that sound like my dogs, but not really. Hi?
Ellie, can you guys stop screaming? I know, but I'm talking to my mouth trigger.
Maybe that's what I was hearing. I've also got kids in my neighborhood that are outside screaming, so I just want to make sure my dog wasn't injured and yelping. So factor that for me. That's a very simple quadratic.
Just -3 and 1. So y minus 3, y plus 1.
Okay. So what are my two solutions?
3 and -1.
And what is the sum of the two solutions?
2.
Now, had you used the quadratic formula on that, you'd still be working on it.
Yeah, it would take more time.
Yeah, and the quadratic formula is always the longest way to go. If you can factor something, it's always going to be quicker than using the quadratic. Quadratic formula would eventually give you the answer. You'd get 3 and -1.
Mm-hmm. That just takes more time.
Yeah, and especially since we are trying to focus on speed. Now this one, number 15, what's the quickest way to do that?
Just do 7 divided by 8.
In your calculator. Do it in your calculator and tell me what the answer is.
So it's 8.75, so C.
Okay. I was just curious to make sure that you didn't have your calculator set on 2 places only. So your calculator gives you out several decimal points.
Mm-hmm.
Good. Because notice that if it happened to be on the default of 2 decimal points only, you'd have gotten 0.88 on your calculator.
Mm-hmm.
Okay, a marble problem. My favorite problems are the marble.
Should I be on degree or radian?
Well, generally degrees for this test.
Okay.
That's not to say there won't be a trig question on radians.
Okay, so just if it's trig.
Do you know how to switch it?
Yeah.
It's actually easy on the TI-84. Where it's tough is on the Inspire to switch.
Yeah, I have to switch it a lot for physics and math.
Yeah. No, as long as you know what you're in.
Mm-hmm.
A simple way, well, it's just a look. It shows you whether you're in radians or degrees. So.
Mm-hmm.
All right, the marble problems. I love marble problems and age problems. Same kind of problem. If Billy is 3 times as old as Sue and Sue is 2 years older than Bill, when will they all be the same age? Problems like that. Okay?
Okay.
The reason is they are the classic back-solving problem. You do not want to do this algebraically. Could, but it's not the fastest way to do it, ever. And the key is how many marbles does Billy have? When the very last question is a simple question like that, then we can absolutely start with the answers and plug it in and see if it's correct. Not only that, but if we're wrong, we'll know whether we need to go lower or higher.
Okay.
Okay? So remember, these kind of problems are ideal for back solving. Now, if that last question said, what's the sum of Billy and June's marbles, then it wouldn't be a back solving problem. But when it asks a singular thing, so where are we going to start if we're going to back solve it?
Probably the middle.
It's the one thing that Sycamore Learning does wrong in their seminar, is to tell you that. It's not horribly wrong, but it actually is. You want to start with the second lowest or the second highest.
Okay.
Okay? Just trust me. I won't go through my explanation. But yeah, Sycamore Learning tells you to start with the middle, but that's absolutely wrong. So I usually start with the second lowest. Okay?
Okay.
Billy has 20 marbles, right?
Mm-hmm.
Okay, now let's go back and see if that makes sense. How many does June have?
She has 20 more than Billy.
How many does she have?
So she would have 40.
Okay. And how many does Maria have?
60, which does not equal 100.
Uh-huh.
So then it probably had to be 16.
The answer has to be 16, right?
Mm-hmm.
And we're done with the problem. You do not want to go in and plug in 16 and make sure you're right. You absolutely know that 20 is too many for Billy to have. So I got to have Billy having less, and that will get this total to where I need it to be. And that's why the second low is a better choice than the middle. Notice that had I done the middle,
then it would have taken longer.
Well, I would have gotten a bigger number than 120, and I would have known that I need a smaller number, but I still got to do work.
Mm-hmm.
In other words, I got to pick either G or F and try one of them, and then I will have the answer. So whenever you have a problem like this that you can back solve, you're always going to get the answer after 2 tests.
Okay.
It doesn't matter whether you start in the middle or you start with the second low or the second high. The most number of tests you're ever going to have to do is 2. However, when you start with the second low, you're getting the answer correct 40% of the time, because you're going to get it whenever it's G is correct or whenever F is correct. You're going to get it on that first trial. Same if you start with J. You're going to get it whenever J is correct or K is correct. You're going to get it with one calculation only.
Mm-hmm.
Whereas when you start in the middle, it definitely tells you whether you need to go up or down, but you still have to do another calculation. So twice as often, 40% of the time as opposed to 20% of the time. Starting with,
I will do that.
What's that?
I said I'll do that then.
Yeah, no, start with either the second low or the second high, unless it's a problem that says, what's the maximum marbles that Billy can have? Well, now you start with the biggest number, because it doesn't do any good to figure out if 16 works. You want to know whether the biggest number works. And if it says, what's the minimum, you start with the smallest number. So you don't always start in the middle or with the second low and the second high. It depends on the question. And this is a classic back solving problem where you not only want to start with the second low or the second high, but you're certain that if your first pick is not correct, you know which way to go. You know to either go higher or lower. Now, if this number would have come in at like 80, well, then we would have needed another calculation. Then I do J. In other words, if G doesn't work, and it tells me I need a bigger number, I'm doing J, and I'm going to know my answer after J. Either J will be correct, or I'll know that H or K is correct. So I will never have to do more than 2 answers when I back solve a problem like this. That's what makes it such a great technique.
Okay.
$17. Tell me how you're doing this as you look at it and work on it.
Okay.
Because there are some traps that are just time wasters.
I mean, would you just plug in 6 for the X and then solve for Y?
The trap that you don't want to do here is to graph it. That does no good at all. It takes a lot of time to graph. And it's not going to help you answer the question. So yes, in other words, this equation has to satisfy if X is 6, then Y has to be something specific, right?
Mm-hmm.
So I'm going to plug in that, and then I'm going to solve this for y, and there can only be one answer. So I get minus 2y equals minus 14, y equals positive 7. So that's the y coordinate when x is 6. In other words, it's a pure algebra problem. And if I went to the trouble to try to graph it, well, first of all, I might have to solve that for y. I suppose there's a couple of ways I could do it, but I don't know. I'm not sure how that would graph. I guess when x is 6, y is 7, that point must be on the graph, so it must be something like that. But having a graph of it doesn't help me. I don't know what that point is. The only way I can figure it out is to algebraically substitute 6 for x, just like you did.
Okay.
Parallel lines. The classic problem that you're gonna see 3 or 4 of these on the test. Parallel lines cut by a transversal. Now, remember a couple of problems back I said that when you see a question like that, it doesn't make it a good back solving problem, because they're not asking for a single quantity. They're asking for the value of two things being subtracted. So it's going to be really hard to go through the answers and try to figure out, in other words, back solving doesn't work when you have these kind of questions.
Okay.
Okay. So put this into an equation.
Okay.
Got a sentence right there. P is
Equal.
means equal. What's 20 degrees less than 3 times Q? How do I write that?
20 minus
Q.
3Q.
That is the biggest mistake that everybody makes on that. You cannot write it from left to right. And they always word it like this. Always, 100% of the time. Because not everybody, but a lot of people are going to make the mistake of writing that 20 minus 3Q. Well, it isn't. It's 3Q minus 20. Notice that it says 20 degrees less than.
Okay.
That means the 20 is being subtracted from the 3Q. Okay? So we get this equation from that middle sentence. That's one equation and 2 variables. I can't really solve that. I certainly can't solve it for P minus Q. But there's another equation that we know is true, which is what? Given the fact that we're dealing with 2 parallel lines and a transversal, what's the relationship between P and Q?
They equal 180.
P plus Q equals 180. Now we have a second equation that we can solve. We're going to solve this using substitution or elimination?
I would do substitution.
Okay, because one of them is fully defined, that one. So I'm just going to take the second one, and wherever I find P, I'm going to substitute 3Q minus 20 plus another Q equals 180. Well, that's 4Q equals 200. Q equals 50. If Q equals 50 and P plus Q is 180, then P has to equal 130. Now, what's the answer? What's P minus Q?
$80.
Yeah. but we had to solve for each variable. I could not solve for P minus Q without solving for P and without solving for Q. And the only way to do it really is these two equations, each with two unknowns. You can always solve those. Well, I shouldn't say that. Some of them have no solution, but and some of them have an infinite number of solutions. But two equations and two unknowns will almost always produce a unique solution. Especially, they may ask one question that has no solution, but and I know they actually do. Speak of the devil. Question 19. Which of the following systems of equation does not have a solution? What would be the hard way to do this?
Try every single one.
Solve every one of them, right?
Mm-hmm.
That's going to take forever.
Mm-hmm.
There's a better way to do it. Let's talk about this. If I tell you that x plus y equals 10, and I also say that x plus y equals 9, can you give me a solution to that?
19.
No. If you solve it using elimination, and I subtract,
1.
I get 0 equals 1. 0 can never be equal to anything but 0. Whenever you get a solution where one number equals a different number, that means no solution. Okay?
Okay.
Well, look at those. Now, here, if I told you x plus y equals 10, and 2x plus 2y equals not 20, but say 21, that's the same problem. In other words, I've got two things that can't be reconciled. If I try to solve it by elimination, I'm going to get one number equals a different number. So it's these kind of things that cause no solutions. Well, look at each of those systems of equations and tell me which one most approximates this kind of a thing. E. Notice what's going on in E. The left side of that equation is exactly 3 times that equation.
Oh.
Which means this would need to be 18 for both of those to be true statements. And if it's anything other than 18, I got no solution. And it's 7. So if I were to try to solve this by multiplying top and bottom by 3 and then subtracting, I would end up with 0 equals, let's see, 18 minus 7, 11. That's no solution. So if you tried to do it manually, you'd solve that one, you'd solve that one, you'd solve that one, you'd solve this one, but there's a reason they put this at the end, is they don't want you to solve it that way. They don't want you to have to try to solve each one. That'll take 2 to 3 minutes. And you can only average a minute per problem.
Mm-hmm.
So that's when you see a problem and you can say that, wow, if I do it that way, it's going to take 3 minutes. There's always a quicker way to do it. And
okay.
The biggest thing you have to understand is that this thing, let me just say one last thing and then I'll let you go. If I said x plus y equals 10 and 2x plus 2y equals 20, And now if I go to solve it, I get 0 equals 0. That's an infinite number of solutions. So you have three possibilities on these systems of equations. You can have no solution, you can have an infinite number of solutions, or you can have a specific solution.
So no solution is when 0 would equal
a number, or
a
2 equals
number.
3, or if you get one number equaling a different number, that's impossible. That means no solution.
Okay.
You get one number equaling the same number, that just
Then that's
that's
all real.
going to be true for all x and y. And the reason
Okay.
is because that first equation is not any different than the second equation. Notice the second equation is just a multiple of 2. And the only way you can solve a system of equations is if you have two independent equations. You can't just have a starting equation and then multiply it by 2 to get a second equation and hope to solve it. That's not going to solve it. You've got to have two different equations. If I said x plus y equals 10 and x minus y equals 10, that's two different equations. I can come up with a solution there. The only solution is x equals 10, y equals 0, but that's a solution.
Okay.
Okay? All right, I'm going to make a note as to where we left off, and we'll just pick up from here. We got through number 20. Tomorrow at 11:30, correct? Okay. And you know how to handle the meeting ID directly now?
Yep.
I can just text it straight to you?
Yep.
I will talk to you tomorrow at 11:30.
Okay, perfect. Thank you so much.
All right, bye-bye.